This lesson deals with supplemental problem 8.7. You can find this problem in the ECE202 ebook in the Chapter 8 Supplemental Problems on page 6. Given the circuit, could you solve for V of t in steady state? We'll again use our three-step algorithm that takes a time domain circuit, maps it to the frequency domain, do the analysis in the frequency domain like a DC circuit, and then map back into the time domain. Our voltage source 10 cosine of 500t plus an angle of 0. So the magnitude is 10, the angle is 0, and the frequency is 500 radians per second. 12 ohms is still 12 ohms, 4 is still 4. J omega L is going to be equal to 500 times 2 milli. That's going to be 1,000 times a milli, just equal to 1. So J1 ohms for the impedance of the first inductor. This one is 4 times larger, just simply multiplied by 4. This impedance is minus J over omega C, so omega is 500 times 500 times 10 to the minus 6. The reciprocal of that product is equal to 4, so minus J 4 ohms. To solve for the voltage cross here, we could do that if we knew the total impedance between these two nodes. So let's combine everything. Got these three in series, but J4 added to minus J4 will cancel. That's also called resonance. So we're just left with a 4 ohm resistor in parallel with a 12. So the product over the sum, that would be 48 divided by 16, and that's equal to 3. So we have one impedance here, whose value is just real, 3 ohms. And this current is the same as the current in these two in parallel. So we can use the voltage divider, using the total voltage across it, times the impedance of the voltage that we're interested in, over the sum of the two, which would be 3 plus J1. This into polar form, we have 3 at angle 0, 10 at angle 0, and this would be in the first quadrant, a little bit longer than 3. Again, it's the square root of 3 squared plus 1 squared. And then the angle is the arctangent of 1 divided by 3. It turned out to be 18.4 degrees. Again, one needs a calculator that has rectangular to polar conversion or vice versa. So we enter 2 numbers and we take out 2 numbers. You have to learn this technique for the calculator that you're using. There are many on the market. You can find one that works for your budget. 10 times 3 divided by 3.162. A little bit less than 10 because this is about equal. So 9.487 seems reasonable. 0 plus 0 minus 18.4. And then lastly, to convert to the time domain, we're going to put the cosine of omega t between our magnitude and angle. So our final answer then is 9.487 times the cosine of 500t minus 18.4 degrees, and the units are volts. This is the value in steady state. And this is supplemental problem 8.7.